Dear students, welcome to the video lecture sessions of operating systems. So in the last video, we have discussed about operating system scheduling algorithms, that is shortest job first and shortest remaining job first. In continuation with that, we are going to discuss about the next scheduling algorithm in this lecture video. So we have completed the basic concepts and some scheduling algorithms. So in this, we are going to discuss about priority scheduling algorithms. So by the end of this lecture session, you can be able to define and apply priority scheduling algorithm to find the average waiting times for the given processes. Priority scheduling algorithm, as the name itself it is telling you, priority. So priority is a number, that is the number is associated with each and every process. An integer number is associated with each and every process, that is called as priority. So CPU is allocated to the process with the highest priority. So smallest integer is equals to highest priority. For example, process 1 is associated with 1, that means it is having highest priority. If process 2 is having 2, process 3 is having 3, then highest priority is P1, second priority is P2, third priority is P3. That is smallest integer represents the highest priority. So here we are having two types of scheduling algorithm, preemptive and non-preemptive. The preemptive and non-preemptive we have already discussed in the previous lecture videos. So this shortest job first is a scheduling, priority scheduling, where priority is the inverse of predicted next CPU burst time. So when you are giving the priority, so priority will be given first. Instead of taking the shortest job, we are taking according to the, we are considering the process according to the its priority. So with the problem with this priority scheduling algorithm is starvation. That is, even though if a job is very short, for example, here P1, P2, P3, three jobs are there. If its burst time is 2 and its burst time is 25, its burst time is 35. So this is burst time, these are the processes. If the priority is in this way, priority 1, first priority, second priority, then third priority. So even though its burst time is very less, P1 burst time is very less, but it have to wait till the process 3 and process 2 completes. So the low priority process may never execute. That is the problem. That is the problem, and that kind of situation we call it as starvation. See, even the process 1 is requires only 2 units of time, but it have to wait up to 60 units of time, because these two processes are having highest priority. And for this, the solution is, as the time progresses, increase the priority of the process. So you have to change the priority of this process, even though if when this priority is given first, but it is waiting from a long time, so that must be given with the priority. So let us solve one problem in the priority scheduling algorithm. Let us solve this one, and we will try to find out the average waiting time. So there are several processes given, process 1, 2, 3, 4, 5, and the corresponding burst time has given and priority has given. So the same problem we will execute one by one step, and we will find out the average waiting time, and let us compare whether our calculation and this slide is same or not. Let me write these processes. So first one is process. So there are 5 processes: P1, P2, P3, P4, P5. There are 5 processes, and the corresponding burst times are 10, 1, 2, 1, and 5 are the burst times. For this, these are the given priorities. Priority. So the priority first P1 is given with priority 3, P2 is given with first priority, P3 is given with fourth priority, P4 is given with fifth one, that is the last priority, P5 got second priority. Now to find out the average waiting time, as we know, we have to draw the Gantt chart. So let us draw the Gantt chart. So Gantt chart will start with 0. So first priority is given with process 2. So process 2 will be considered and its burst time is 1. So P2 will come first. The second priority goes to process 2. Sorry, process 5. So process 5 is given with second priority and its burst time is 5. So on timeline it is 6 units of time. The next priority goes to process 1. So take process 1 and its burst time is 3 units of time. So 6 units of time is already completed. So 3 units of time, that is 9 units of time. So P1 completed, P2 completed. The next priority is given with P3. So P3 will come the next and its burst time is 2. So 9 plus 2, it is 11. And the last one is P4. P4 is the last one. So its burst time is 1. That is 12. Right? So now calculate individual waiting time. Let me check this once again. P1 so these are the processes which are given to us, and these are the burst time, and this is the priority. Now let us construct this Gantt chart for this so that we can find the average waiting times, individual waiting times, and average waiting times. So as you know, Gantt chart will start from 0 timeline. So first priority is given with P2. P2 will take 1 unit of time. Then the next priority is given with P5. So P5 will consume, what is the burst time? 5. So 1 plus 5, it is 6. The next priority is given to P1. So third priority, it takes 10 units of time. So it is 16. After P1, P3 will take place and its burst time is 2, that is 18. After P3, P1 is the last process. Sorry, P4 is the last process. It takes only 1 unit of time, that is 19. So this is your Gantt chart, right? So now find out the waiting time for 1 by 1 process. So waiting times. Waiting time for the P1. What is the P1 waiting time? So here it is P1. So P1 has waited up to 6 units of time. Then P2 has not waited for the CPU. So it's having 0 waiting time. And P3 has waited up to 16 units of time. So P3 is 16. Then P4 has waited up to 18 units of time. Then P5 is 1 unit of time. So now average waiting time, that is P1 plus P2 plus P3 plus P4 plus P5 by 5, that is 6 plus 0 plus 16 plus 18 plus 1 by 5, that is equals to 41 by 5. Sorry, It is not 8, it is 5. So this is 8 point something. So 8 units of time, 8 units of time is the average waiting time. So by using the priority scheduling algorithm for the given process, 8 units of time. So now let us check this. So 8.2 ms milliseconds of time it is going to take by using the priority scheduling algorithm. So in this way, you're going to apply the priority scheduling algorithm onto the given processes. So in the next class, we will discuss about round robin scheduling algorithm, and thank you.